We want to solve this quadratic equation by the square root method. So before we actually go to solve, let's make sure that we're actually allowed to use the square root method on this equation. So the 5x squared is a quadratic term because of the x squared. The 20 is a constant term because there's no x. And then the 0 is also a constant term because there's no x in those terms. So because there is no linear term, then we are allowed to solve using the square root method. Okay, so step number 1 for the square root method would be to determine what is being squared, and we want to get that by itself. So we find the square and we say, what is the base for that exponent of 2? And the base is only the x squared. So it's only the x. So x squared is what is being squared, so we want to get that by itself on one side. So that means that we want to get rid of the 5, and we also want to get rid of the positive 20. So I have two things that I want to move to the other side of the equation. Okay, we always do our adding and subtracting first. So I'm going to subtract 20 from both sides of the equation first. So now I have 5x squared equals negative 20. Okay, I still want to get x squared by itself, so I need to get rid of the 5. The 5 is being multiplied to the x squared, so I'm going to divide both sides by 5. So now I have x squared is equal to negative 20 divided by a positive 5 is a negative 4. Alright, so step 1 is to figure out what's being squared, and we want to get that by itself. Sometimes we have to do some adding and subtracting and dividing. Okay, so we always do the adding and subtracting part first, and the last thing we do is any dividing. Okay, step number 2. We want to apply the square root and the plus minus to both sides of our equation. Okay, so I'm going to apply my square root plus minus. Remember that the square root goes on top of everything that you see on the right hand side, so including the negative and the 4. Alright, step number 3 says that we want to simplify those radicals and solve for x. So the square root of x squared, we know that's x. Bring down the plus or minus. What about the square root of negative 4? Okay, so anytime we have the square root of a negative number, the procedure is always the same. So we're going to split this up into two square roots, multiply together. We're going to put negative 1 in the back square root, and then in the front we're going to put the positive version of that number. Okay, the square root of negative 1, it's I. Square root of 4, that's 2. Okay, if you need to, you can think about that as 2 times 2, find a group of 2 and bring it out. But hopefully we know by now that the square root of 4 is 2. So remember, we're going to take that answer, we're going to put it behind the plus and minus sign that we see. Okay, so that is our final and simplified answer. You could also write this as x equals positive 2i and negative 2i as those two x solutions separately. All right, we want to solve this equation, again using the square root method. So let's verify that we're allowed to. Here's the quadratic term. Here's a constant term and a constant term. As long as we have no linear term, then we are allowed to solve using the square root method. Alright, so step number 1, we want to figure out what's being squared, and we want to get that by itself. So x is the only thing being squared, so I want to get x squared alone. So that means that I need to get rid of the 7 and also the negative 22. Okay, we're always going to do our adding and subtracting first. So I'm going to add 22 to both sides of the equation. Okay, because of the negative that's there, negative 22 plus 22, that's going to make these two cancel out. So if we have subtraction, then we're going to do the opposite operation of addition. Okay, so when we do that, we get 7x squared equals, let's see, 3 plus 22, that's 25. Okay, we still have something else to do, right? We want to get rid of the 7 that's being multiplied times the front of x squared. And so I'm going to divide both sides by 7, and those 7's will now cancel out and go away. So now I have just plain old x squared, which is exactly what I wanted, by itself on one side, equals 25 divided by 7. Okay, so step number 2 is we're going to take that equation and we are going to apply square root to both sides. So square root, plus and minus in front of the square root. Okay, so be really careful, make sure you don't forget that plus and minus. Okay, step number 3, we want to simplify the radicals. So the square root of x squared, we know that's x. We're going to bring down that plus or minus. And now I have a fraction underneath a radical symbol. So remember our steps for simplifying. When we have a fraction underneath a radical symbol, we're going to separate, we're going to simplify, bring out any groups of 2, and then lastly, if we need to, then we are going to rationalize. Okay, so let's separate. We have square root of the top, which is the square root of 25, divided by, now the square root of the bottom, which is 7. Okay, what about simplifying now? Okay, what's the square root of 25? Well, that's 5. 7 is prime, so I'm not going to be able to find 2 of a kind, so nothing's going to come out, so we just have square root of 7. Okay, so we simplified the radicals as much as we can, bringing out any groups of 2. Rationalize. Okay, do we still have a square root left in the denominator? Yes, we do. So we are going to rationalize by multiplying top and the bottom by exactly the square root that's in the bottom. Okay, so our final answer here would be x is equal to plus or minus. Now, 5 is outside of the radical, 7 is underneath. Remember, anything that's outside of the radical has to stay outside of the radical. Anything that's inside is going to stay inside. So this time we get 5 times the square root of 7. All of that over 7 times 7 underneath the square root. So inside times inside, the answer gets multiplied together inside. Okay, we'll take out that group of 2, bring out one representative. Since we circled and crossed out everything underneath, then the radical symbol goes away. So our final answer here is going to be x is equal to 5 times the square root of 7, all of that over 7. Okay, and remember that we can also write this as 2 separate solutions, positive 5 times the square root of 7 over 7, or negative 5 times the square root of 7 over 7. For this example, we want to solve the quadratic equation using the square root method. So let's verify first that we can. Here we have the quadratic term, a constant term, and another constant term. So as long as we have no linear term, then we are allowed to use this square root method. So step number 1, we want to isolate or get by itself whatever is being squared. So whatever that exponent of 2 applies to. So we know that that square only applies to the x that's directly in front of it. So that means that we need to get rid of the 5 that's being multiplied times the x squared and also the negative 11. Okay, when we start to get things by themselves and we start to do operations, we always do adding and subtracting first before we do any dividing. So I'm going to add the 11 to both sides. Okay, why am I adding? Okay, when I see a negative sign in front of a term, I'm going to do the opposite sign. So I'm going to add 11 to both sides. Okay, so we get 5x squared. The 11s are going to cancel out. 0 plus 11, that gives me a positive 11. Okay, we're not quite done yet. We still want to get rid of that 5. Remember, our goal here is to get x squared by itself. So we're going to do that by dividing both sides by 5. Remember that the original operation connecting 5 to x squared was multiplication. So I'm dividing because it's the opposite of the multiplication. Okay, so the 5's cancel. I'm left with x squared is equal to 11 over 5. Alright, so step number 2 says after you've gotten x squared by itself, we're going to take the square root of both sides, and we want to insert the plus and minus in front of the square root that's on the opposite side of the equal sign from x. Step 3, we want to simplify those radicals. What's the square root of x squared? Okay, good. We get x equals, bring down the plus or minus. Okay, once again, we have a fraction, and that fraction is underneath that big square root symbol. So if our radicand is a fraction, then we have to follow our steps for simplifying fractions and radicals. Separate, simplify, and then rationalize. Okay, so let's separate. We're going to do the square root of the top divided by the square root of the bottom separately. Simplify. That means we're looking for any group of 2 underneath any radical. 11 is prime, so that's by itself. We're not going to be able to find a group of 2 there. 5 is also prime, so we're not going to be able to find a group of 2 there either. So that's done. Rationalize. Do we still have a square root left in the denominator? Yes, we do. So we're going to multiply by exactly the square root that we see in the denominator. So I'm going to multiply top and the bottom of this fraction by 5. Okay, so inside times inside, the answer stays inside. So at the bottom I get 5 times 5. Okay, the whole point is that we created a group of 2 underneath on the bottom. Circle it, cross it out, bring one representative out. Okay, so our final answer here is x is equal to plus or minus square root of 55, all of that divided by 5. Remember, when we circle everything underneath and cross it out, the radical symbol goes away, and we're left with just whatever was in front of that square root. Okay, so our answer is x is equal to plus or minus square root of 55 over 5. Now remember, we're not allowed to divide the 5 into the 55 or cancel anything because the 55 is inside the square root and the 5 is outside of the square root. Okay, we can also give our answer separately as the positive version and the negative version. Okay, so you can write it the long way or the short way. Both of those are perfectly good answers. Now this example is where things start to get a little more interesting. So first of all, we want to solve this equation using the square root method, but are we actually allowed to? Okay, remember that the first step for solving an equation by square root method is to isolate whatever is being squared. So we want to get whatever is being squared by itself. So here we have the exponent of 2. What is the base for that exponent? Well, the base for that exponent is everything that's in the parentheses. So what is being squared is actually this entire quadratic term. Okay, so because of the parentheses, that's going to group that into one big quadratic term. So that might seem a little strange at first, but we're going to get whatever is being squared by itself, and the parentheses indicate that all of that is being squared at one time. Okay, so that's one big quadratic term. The 4 is a constant term, so we have that there is no linear term. So we are allowed to use the square root method. Okay, so one thing that we want to be careful about is that we do not want to try to write out x minus 3 times x minus 3 and do any foiling. Okay, if you do write out x minus 3 times itself and FOIL, watch what happens. Okay, I'm just going to FOIL this. Combine my like terms. You notice what you would introduce to the equation. Here's a quadratic term, here's a constant term, but then here's a linear term. And if we're solving using the square root method, we don't want to introduce a linear term to the problem. So we are not going to FOIL that out. And in fact, we're just going to follow the steps for solving using the square root method. Okay, so I'm going to erase that, give us a little more room. Okay, so the square root method says get whatever is being squared by itself on one side. And we've determined that that is what's being squared. So step number 1, done. Okay, step number 2. we're going to take that equation that we got from step 1 and we are going to apply square root to both sides. So square root, plus minus. Okay, so we're going to do exactly the same thing we did before. Square root, plus minus. The plus minus goes in front of the square root on the opposite side of the equal sign from where the x is. Okay, step number 3, we want to simplify these radicals. Okay, so this is new. How do I do this? Okay, x minus 3 quantity squared. What does it mean to have x minus 3 squared? Well, that means x minus 3 times x minus 3. When I'm simplifying this radical, our index is 2, so we're looking for a group of 2 of a kind underneath. So what we have here is a group of 2 of a kind. So that's x minus 3. So we're going to circle that group of 2, cross that group of 2 out, and we're going to bring one representative out of the parentheses. So we're going to bring out x minus 3. So one representative of that 2 of a kind. Okay, since we circled across everything out, the square root symbol goes away. So our shortcut really from now on would be, once we isolate that quadratic term and we take the square root symbol and the square are going to cancel each other out, and we're left with the base for that square. So we're left with just what's inside of the parentheses, x minus 3. Alright, what about what's happening on the right hand side? So on the right hand side we have the plus or minus and we have 4. Okay, and if you need to, you can write that as 2 times 2, all those prime factors, circle, cross out, bring one representative out. And remember that representative goes right in front of the square root but behind the plus or minus. So that's 2. And of course, you can just say the square root of 4 is 2. You don't have to go through that process. But just to show that you can, and you get the same answer. Now this is where things start to get a little more interesting. So I'm going to put a couple of stars by this. Okay, so this is where things start to get a little more interesting. Have we solved for x? And the answer to that question is no. We have not gotten x by itself. Part of the problem though comes when we try to add 3 to both sides to get x by itself. Is this a plus 2? Yes. Is it a minus 2? Yes. So it's both. So that's a problem. Okay, when I add 3, am I adding a 3 to the 2 that's positive or to the 2 that's negative? Okay, so what I want you to do when you get to this stage where you have the parentheses, I want you to rewrite this as 2 separate equations. Okay, so it's x minus 3 equals positive 2 on the one hand, but then x minus 3 equals a negative 2 on the other hand. So I want you to take that plus and minus that we put in, and I want you to use that to separate this into actually 2 different equations using those 2 different numbers. Okay, so it's a positive 2, but we can't think of it as both a plus 2 and a minus 2 at the same time, so we're also going to rewrite that equation. Same left-hand side, but the right-hand side is going to be split into a positive and a negative of that number. Okay, so now we have 2 separate equations that we want to solve. Alright, so to solve the equation on the left, I'm going to add 3 to both sides. And I get x is equal to a positive 5. Okay, on the right hand side, I'm going to also get x by itself by adding a 3 to both sides. Okay, so I get x is equal to negative 2 plus 3 is a positive 1. Okay, so you notice that my answers are 2 different numbers and they both turn out to be positive. That is perfectly fine. Okay, so when you have this plus or minus and you still need to do some work to solve for x, I want you to separate this into 2 separate equations using that plus or minus, taking it as a positive and then taking it as a negative. So we're going to split that up into 2 separate answers, kind of write it the long way instead of using the shortcut way. Then solve those 2 equations individually for x. Okay, and whatever you get, that's what you get. That's perfectly fine. Okay, so here's a big no. Okay, here's a big no. This sometimes happens, and so you don't want to let this happen to you. Okay, so this is, remember, this is a big no. Don't do this. Sometimes people think, well, I'll just leave it as plus or minus and I'll add 3 to both sides, and they get something like x is equal to plus or minus 5. Okay, that is not the answer that we got over here. Okay, so that would be wrong. If you add 3 to a negative 2, you do not get a negative 5. Okay, so this is a big no. Don't try to answer the question or solve for x, keeping the plus or minus there and then bringing something over to the same side to join it. Okay, so this is the process that I want you to use when you have parentheses in your problem and you have to do a little bit more work to solve for x and you have that plus or minus. Separate into two separate equations, in other words, write it the long way, and then solve for x. We want to solve this equation using the square root method. Step 1 of solving using the square root method is to isolate whatever is being squared. So figure out what's being squared and we want to get that by itself on one side. So here's the exponent of 2, here's the square. What does it apply to? Well, it applies to everything that's in the parentheses directly in front of it. Okay, so that means it applies to this entire group, including the parentheses. Okay, what does it not apply to? Well, it does not apply to the 2. So the 2 is not part of what's being squared. So we need to get rid of that and we're going to move it to the other side. So I'm going to divide both sides of this equation by 2. So why am I doing division? Okay, I'm doing division because that is being multiplied times the front of that parentheses. So to undo multiplication, we do division. Okay, so I have x plus 5 quantity squared is equal to negative 150 divided by 2. Okay, if you need to, you can pull up Desmos. Okay, so negative 150. If I divide that by 2, I get negative 75. Okay, so anytime you need to use your calculator, make sure you go ahead and break that out. That's perfectly fine. Better to get it right using the calculator than to get it wrong. Okay, so that's step 1. Now we have isolated what is being squared, and now that is by itself on one side. Okay, so let's talk about a no really quick. Another big no. Sometimes I see this happen. Okay, say, oh, well, I want to get rid of the 2, I'll just multiply it in. Why can't I just distribute? Well, the problem with that is PEMDAS. Okay, remember order of operations, PEMDAS. Okay, parentheses say do whatever's inside of the parentheses, so add or subtract or do anything that you can inside of the parentheses. I can't add x plus 5 because they're not like terms, so that's taken care of. The next thing that I would have to do is exponents. Okay, so I have to square this out. But I don't want to square that out, and we already talked about why. I don't want to square that out because if I square that out, I'm going to introduce a linear term. So I don't want to do that. So I don't want to do exponents. What is distribution? Isn't that multiplication? That is multiplication. I'm not allowed to do multiplication before I perform the exponent. If I don't want to perform the exponent because it would introduce a linear term, then I can't perform the next operation of multiplication. So distribution is multiplication. I'm not allowed to do multiplication if I'm not willing to first do the exponent. Okay, so be careful that you're not doing a distribution. If you're doing a distribution into the parentheses with the square there, then you're violating the order of operations. Okay, so that's an aside there, a big no. Make sure you're careful. If you had that question, now it's answered. Okay, so step number 2. We're going to take our equation and we're going to take the square root of both sides. Okay, so we're going to apply square root to the left side, square root to the right side, then we're going to put that plus and minus in on the opposite side of the equal sign that has the x. Okay, so step number 3, we're going to use the shortcut this time. We know that x plus 5 squared is a group of 2. And we know that if we circle that group of 2, cross it out, bring it out to the front, we know what's going to happen. Okay, we also can just say that what we know is going to happen eventually is that the square root symbol and the square are going to cancel each other out, and what we're left with is just what's inside of the parentheses, x plus 5. So that's a shortcut that I'm going to ask that we go ahead and just start using. Okay, you can do it the long way if you want to, like we did on the last problem, but I'm just going to start using the shortcut. Okay, on the right side I'm going to bring down that plus or minus. And now we need to simplify the square root of 75. Okay, so the square root of negative 75, right? So we have a negative. What do I do when I have a negative number underneath the square root? Okay, good. I'm going to separate that as two radicals, so two square roots multiplied together, and we're going to put -1 in the back square root. Okay, in the front, I'm going to put the positive version of that number, so I'm going to put a positive 75. Okay, what's the square root of -1? We replace that with I. 75, what are the prime factors of 75? What is that, 3 and 25? Keep the 3, that's prime. 25 breaks up as 5 and 5. So we have 3 times 5 times 5. So we do have two of a kind, and I can bring out 1 5 for that group of 2. So I get 5 times the square root of 3 times the I. So everything that I just did, I'm going to put behind that plus or minus. So that's 5 square root of 3 times I. Okay, now we need to solve for x. I need to get x by itself. Right now I have an x plus 5, so that's not quite good enough. So I need to actually go a little bit further, and I need to subtract that 5 from both sides. So my suggestion at this stage is, since you have something else to do to get x by itself, and you have the plus or minus, I'm going to suggest that you just go ahead and get in the habit of separating it as the positive version of that answer and the negative version of that answer. So the left-hand side, x plus 5, that stays the same, so that's not changing. But the right-hand side, we're going to recognize that that is both a positive and a negative answer. Okay, so we're going to treat that as a positive on the one hand and then a negative on the other. Okay, so be careful here. Something else that we need to be careful about. Let's say that I do solve this equation by subtracting 5 from both sides. Are those like terms? Okay. Can I add or subtract, let's say, can I subtract 5 and get square root of 3i? So remember that when I combine like terms, I have to look past the number for each term. So if I look past the number for this term, 5, I get square root of 3i. When I look past the -5, I see nothing. So I'm actually not allowed to combine these. These are not like terms. So you want to make sure that you're on the lookout for following the rules that we talked about. When you combine terms, make sure they're like terms first. So whatever comes after the number out front of that term has to match exactly in order for you to combine those numbers. So the best that I can do is let them sit side by side. So bring the -5 down and then bring the second term down plus square root of 3, or plus 5 square root of 3i. Okay, so that's actually as good as it gets. It doesn't get any simpler or better looking than that. Okay, the same thing is going to happen on the right side. When I go to subtract 5 from both sides of the equation, I'm actually not allowed to combine them because once again they're not like terms. When I look at the top term after the number, I have square root of 3i. When I look past the number here for the second term at the bottom, I have nothing that comes after the number out front of that term. So something that has a term that has something and a term that has nothing cannot be combined. So the best that I can do is just to bring down those two terms. So -5 and then -5 square root of 3i. Okay, so those are my two final solutions, and that's about as good as it's going to get. Now, some of you might be asking, can't I combine those answers? Can I write my answer like this? Can I combine them to write a shortcut? And the answer is yes. You can write it the long way or the shortcut way. Okay? So make sure your 5 in the front is negative. The plus or minus comes from this right here. So it's both plus and minus. And if you want to combine those into one answer to write plus and minus 5 square root of 3i, that is perfectly fine. For part N, we want to solve this using the square root method. So step number 1 is to isolate whatever is being squared. So what does this square apply to? Well, that exponent of 2, that square, applies to everything that's inside of the parentheses. So this is what's being squared. We want to get that by itself on one side. That also means we need to get rid of this negative 72. So how am I going to move that to the other side of the equation so that I have the yellow part by itself on one side? So that's a negative 72, that's being subtracted, so we're going to do the opposite operation. We're going to add 72 to both sides. Okay, so I have 2x minus 5 squared, right? So that's the squared term. We're going to cancel those, and we end up with 0 plus 72 on the right-hand side, so that's a positive 72. Alright, so step 2 says we're going to apply that square root to both sides. So square root, plus minus. Step number 3 says we want to simplify our radicals. So if we have any groups of 2, we want to make sure that we bring them out. So 2x minus 5 in the parentheses squared, that's a group of 2. We've already talked about our shortcut. The square root symbol and the square are going to disappear, and we're left with just what's inside of the parentheses. Okay, we'll bring down that plus or minus. Now let's simplify the square root of 72. It's a positive number, so I just need to figure out the prime factors of 72. 72 is 8 and 9. 9 is 3 and 3. 8 is, what's that, 4 times 2, keep the 2. 4 is 2 times 2. Right, so there's the prime factors of 72. So I'm just going to copy them all down in here. I have 3 of those and I have 2 of those. Alright, so remember we're looking for 2 of a kind, so groups of 2. Here's a group of 2. Here's another group of 2. So we can circle those, cross them out, and bring one representative out. And remember that the representatives that we're multiplying go right in front of the radical, but after the plus and minus. Okay, so I can bring out a 3. Okay, so now I have 2x minus 5 is equal to plus or minus 2 times 3 is 6, and it goes right in between, again, the plus or minus and the square root. So it gets tucked in between those two. What do we have left inside? It looks like we just have a 2 left inside. Okay, so we need to solve for x. We do not have x by itself yet, and our whole goal is to get x by itself once we've gotten rid of that square. Okay, so we have a plus and a minus. My suggestion is always just go ahead and split that up as 2 separate equations. Keep the left side the same, so that's 2x minus 5, but we're going to change the right side based upon the fact that that's really 2 different numbers sitting there. So I'm going to write it as a plus 6 times the square root of 2. So that's one equation. And we're also going to write that as 2x minus 5. Okay, so the left side is not changing. It's the right side that we're rewriting as 2 different ways. We're going to write that as now negative 6 times the square root of 2. Okay, so now let's solve for x. We're going to add 5 to both sides. Right, and actually before we combine and get something like 11 square root of 2, make sure that you're careful. These are 2 separate terms, and we underline what comes after the number for each term, and we want to know, do they match? Since these do not match, these are not like terms. So that means I actually cannot combine them. So the best that I can do is write 2x is equal to, we'll write 5 plus 6 times the square root of 2. So these are not like terms, so they cannot actually physically combine. So we're just going to write them side by side. Okay, what's the last thing that I need to do to get x by itself? Well, I need to divide both sides by 2, right? So that's 2 times x. If I want to get x alone, I need to get rid of that positive 2 that's being multiplied times x. So I'm going to divide both sides by 2. Now when we do this, we put an underline fraction bar underneath everything on the left and everything on the right, and we put the 2 underneath. Okay, so we get x is equal to 5 plus 6 square root of 2, all of that divided by 2. So that is one of our solutions. You might be tempted to divide the 2 into the 2, but remember that's inside and this is outside, so those don't get to mix. You might also be tempted to divide the 2 into the 6. The 6 is outside and the 2 is outside of a radical. So what's the problem? Why can't I divide the 2 into the 6 or cancel common factors there? Well, the reason comes from the fact that that's a two-term thing at the top. If that's two terms, okay, you can think about that if you want to as a binomial, but that's two terms. At the bottom, we only have one term. So remember our rule for canceling binomials and monomials. A monomial only cancels with another monomial. A binomial can only cancel with another identical binomial. Since the top is a binomial and the bottom is a monomial, then we can't cancel pieces of a binomial to cancel with a monomial. So there's no cancellation that can take place. So when we talked about simplifying rational expressions way back on exam 1, this is one of the reasons why we talked about that. It can be really tempting to try to cancel things when you're not allowed to cancel. So make sure you're still following those category rules for canceling that we talked about at the end of exam 1. Okay, so let's solve for x in the second equation. We're going to add 5 to both sides. Once again, we want to make sure that we're combining only like terms. Since these do not match, so the underlined portions do not match, that means they are not like terms and therefore cannot be combined. So the best that we can do is to let these sit side by side. So we have 2x is equal to, I'm just going to go ahead and put the 5 in the front, so that's a plus 5 in the front, and then the negative 6 square root of 2 is going to go behind that. Okay, once again we want to get rid of the 2, so I'm going to divide everything on both sides by 2. So once again, notice that that fraction bar is going underneath everything, dividing into everything that's on that right-hand side. Okay, the 2's cancel, and we're left with x by itself, and that's exactly what we wanted. So now I have 5 minus 6 square root of 2, all of that over 2. And once again, you might be tempted to divide the 2 into the 2 or 2 into the 6, but we just talked about why we're not allowed to do either one of those things. Okay, and I know there's someone wondering, would I be allowed to write my answer as positive 5 plus or minus 6 times the square root of 2 all over 2? And the answer is yes, absolutely. So if you want to write it the shortcut way, instead of writing it as those two separate answers, using the plus and minus for the shortcut, that's perfectly fine. So either the two separate answers, or you can combine them into one using that shortcut with a stacked plus or minus. Alright, this brings us to our final example for our square root method. Okay, step 1 for square root method is to isolate whatever is being squared. So what is being squared here is the entire base of 7x plus 5, everything inside of the parentheses. So I want to get this whole thing by itself on one side. And it actually is already by itself on one side, right? So step number 1 is actually done for us. Okay, step number 2. We want to take the square root of both sides. Okay, so I'm going to write square root on the left side, square root on the right side, square root, plus minus, right? So hopefully that gets to be a habit, square root, plus minus. Okay, now we want to simplify both sides of this equation. So I want to simplify all those radicals. 7x plus 5 squared, we're going to take the square root of that. We know that square root and the square are going to cancel each other out, and we're left with 7x plus 5. Okay, so that's a nice little shortcut that we're going to use. Bring down the plus or minus. What's the square root of 9? Okay, square root of 9 is 3. Okay, so hopefully we're familiar with that by now. Alright, so we still need to solve for x, right? So step number 3 is to solve for x. We want to get x by itself on one side, right? So we simplified our radicals, still need to solve for x. So in order to get that x by itself, you say, well, I need to subtract 5 and divide by 7. Okay, once again, we want to be really careful here. This is a plus and a minus 3. It's really hard to subtract 5 from that and do it correctly. So I suggest that you don't leave those plus and minus stacked, that you separate this into two separate equations. 7x plus 5 equals positive 3, and then 7x plus 5 is equal to negative 3. So we're going to rewrite that plus or minus, so that stacked plus or minus, we're just going to separate that as a positive 3 and a negative 3. So notice that the left-hand side has stayed exactly the same. Okay? The only thing that's changed is I'm not using that shortcut of the stacked plus and minus. I'm writing it as a plus 3 on the one hand and then a negative 3 on the other. Okay, so now we're going to solve for x. I'm going to subtract 5 from both sides. Now, are these like terms? Let's look past the 3 and let's look past the negative 5. There's nothing past the term at the top, so there's nothing past the 3. There's nothing past the negative 5 for the term at the bottom. So those are like terms. We can actually combine them. Okay. The only time that you're going to actually be able to combine them is if they both have nothing. Okay. If you have anything after that number at the top, a square root or an I or anything, you're not going to be able to combine them. Okay, so the only time that you can actually combine them is if both of those terms have nothing. So I get 7x is equal to positive 3 minus 5, that's a negative 2. Okay, if you need to use your calculator, please do. And the last thing I'm going to do is I'm going to divide both sides by 7. Okay, so we get x is equal to negative 2 divided by 7 as one of our solutions. Okay, on the right-hand side, we're going to do the same thing. I'm going to subtract 5 from both sides. Okay, once again, they are like terms, so I actually can physically combine them. Negative 3 minus 5, that's a negative 8. Once again, if you need to use Desmos or a calculator to simplify that, then please do. The last thing I'm going to do is divide both sides by 7. So those 7's cancel out and I'm left with x is equal to negative 8 over 7. Okay, so these are our two final answers for this quadratic equation.